Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about hypothesis testing for the mean with the population standard deviation known. So I'll share my computer screen with you. The average distance thrown by a high school freshman quarterback is 40 yards with a standard deviation of 2 yards. The distance thrown by the quarterback is normally distributed. The coach asks the player to adjust his grip on the football so as to increase the distance he can throw the ball. After the player has adjusted his grip, the coach recorded the player uh, how much recorded the player's basically the distance he throws the ball. Okay, recorded the distance the player has been throwing the ball. He has found that the average distance thrown by the player for a sample of size 20 throws is 45 yards. So he changes his grip on the football and increases his throw for a sample of 20 with an average of 45 yards. The coach thinks that the player's throwing distance is increased. Test the hypothesis at a level of significance alpha equal to 0.05. Okay. So there are two ways to do this problem. First, I will do the formula way, which is critical values and all that. So I will explain what's going on. So solution. Okay. The coach thinks that the player's throwing distance has increased after he has changed his grip on the football. Okay. So this is the alternative hypothesis. Okay, so this is the alternative hypothesis. Alternative hypothesis. So the coach thinks the football player's throwing distance has increased from what it was in the past. Remember, in the beginning, he was throwing 40 yards. So that's your alternative hypothesis or alternate hypothesis. So if this is the alternate hypothesis, the null hypothesis always contains an equal to sign, and the opposite of greater than is less equal to 40. Remember, the null hypothesis always contains the equal to sign. Now, here the alternate hypothesis, the direction of the inequality, the two slanted lines meet at an edge pointing to the right. So this is a right tail test. Okay. My sample size n is equal to 20 throw. My sample mean x bar is equal to 45 because after he changed his grip from a sample of 20, the coach got the average throwing distance is 45. No? And the population standard deviation of his throw is 2. Now I'll draw a standard normal curve. Normal curve, which is basically a Z curve. So this is the standard normal curve or Z curve. Remember, Z is the standard normal variable. Standard normal variable. Okay. So in the center, Z is equal to 0. So Z value is negative on the left of center and Z value is positive on the right of the center. And of course, we have probability on the vertical axis. Okay. So now we will calculate a test statistic. Calculate a test statistic. What is a test statistic? Test statistic is a property of the sample that we have collected. Sample we have collected. Basically, in test statistic, compare the sample mean x bar to the hypothesized population mean. Which is sometimes referred, and also as you will see in the calculator, as you will see. Now, what is the hypothesized population mean? Comes from the null hypothesis. This is my hypothesized population mean. Okay. So, let me move this a little bit up. That's all the information I want. I can also reduce it a little bit. Okay. And then I'll go back to my pen, blue pen. Okay. So how do you define the test statistic? Remember, test statistic is we will be comparing the sample mean to the hypothesized population mean, and this is in terms of the standard deviation of the sampling distribution. Okay. So Z, test statistic, is given by this formula. X bar is the sample mean as compared to the hypothesized population mean, which comes from the null hypothesis, divided by the standard deviation of the sampling distribution, which is sigma divided by square root of n. Okay, so this is the standard error or standard deviation of the sampling distribution. Standard deviation of sampling distribution. Okay. So let's calculate our test statistic Z. Remember, X bar is 45. I put a left parenthesis. Minus hypothesized population mean is 40 divided by, in parenthesis, my sigma is 2 divided by, then we have to bring in the square root with the second button, and then x square, which will bring the square root. Inside the square root, sample size is 20, close the parenthesis, and enter. Okay, so let me move it a little bit more. Okay, do it. So my Z, or the test statistic, is the characteristic or the property of the sample. Oops, I don't want all that, so I have to reduce that, and I'll get rid of it. Okay. So the test statistic, Z is the test statistic, right? So Z is equal to, we'll calculate just like the way we have typed it in our screen. Use the calculator. Here it is. Okay, so it is for parenthesis, left parenthesis, 45 x bar minus hypothesized population mean, which is 40, right parenthesis, divided by left parenthesis, my standard deviation is 2, divided by second x square gives me the square root, inside the square root sample size of 20, and enter. So Z works out as 11.18. Remember, I've told this is a right-tailed test because the two slanted lines making greater than points to the right. That means the rejection region will fall somewhere over here. Okay, somewhere over here. Okay. Now, area of the rejection region, area of rejection region is equal to alpha, is equal to level of significance, which is 0.05. Okay. So if this is my rejection region, this area is over here. Area is alpha. This is where we will reject HC. Okay, in this area. And this area is equal to alpha. In this case, we already know alpha is equal to 0.05. Okay. Now, our test statistic Z is 11.18. Remember, this is Z equal to 0. And this is, we are moving on the positive. Somewhere over here is your test statistic of 11.18. So we calculate the probability of getting a test statistic as extreme as 11.18 or more than 18. That is, p-value is area to the right. Why to the right? Because it's a right tail test. To the right because it is a right tail test. Right tail test. Area to the right of the test statistic. In this case, statistic, which is 11.18. How do I find that in the calculator? Well, we go to second, then verse, okay, and then we scroll down to normal CDF. So my lower is, I'm starting from 11.18. My upper is a very large number on the right. 1, then second button, comma button, will get me the capital E, 99. And my mean is 0 because the standard normal curve, and sigma is 1. Paste, enter, and enter. Okay, let's try that. Second verse, scroll down to normal CDF. We start from lower is 11.18. Upper is I type the number 1, then second button, then comma button, which is a button on top of 7. Gives me the small capital E, 99. It means 1 followed by 99 zeros. Mean is 0, standard deviation is 1. Paste, whenever we on paste, we have to hit enter twice. And this is very small. So p-value is 2.6 e to the power of minus 29. First of all, p-value cannot be greater than 1. So it cannot be 2.6. Whenever we get a number in the p-value greater than 1, we should look for what is after the exponent, minus 29. That means in this case, point, first you put the decimal point, then 28 zeros, and then 2. That means p-value is very small. Point followed by 28 zeros and 2, 6 is almost equal to 0. Notice, compare this p-value with alpha equal to 0.05. P is less than alpha. Okay. Decision, reject 80. Okay, so this is my decision, reject 80. Okay, what is my conclusion? I'll create some more space. Conclusion is at alpha equal to 0.05, there is enough evidence to support H1. What does it alternate hypothesis states? Which is mu is greater than 45. So we are supporting it because we have rejected the null hypothesis. Now let me create some more space and let's do this problem using the calculator. Okay. So let me go back over here. Use maybe a green color pen. Okay. Now we are going to do the same problem over here. Use TI-84 calculator. So we have already concluded that we rejected the null hypothesis and concluded that at alpha equal to 0.05, there is enough evidence to support the alternate, which is should be mu greater than not 45, mu greater than 40. It should be mu greater than 40. Okay. Why? Because P is less than alpha. Okay. And you also saw the test statistic of 11.18 falls in the rejection region in the right tail, which is the shaded region. How to do this with the calculator? So first thing we will do in the calculator, and I'm going to write it over here. Here. Stat, press the stat button, then highlight test on the top row, and then scroll down to z-test. Why z-test? Question is why z-test? Because we know sigma population standard deviation is equal to 2. Okay, population standard deviation is known as 2. So okay, so maybe I can move this entire thing to the top. Okay, now leave it like this. Okay, so let me go back to let me erase this and write it nicely. Okay, because I don't like the way it is. So I'll erase all of this and show you again. Maybe I will use the black pen. Okay. Okay. So now we will use TI-84 to do the hypothesis test. So we press the stat button. Then we highlight test on the top row. Then we scroll down to z-test. The reason we choose z-test is because sigma population standard deviation is 2 is known. Okay, so stat, test, scroll down to z-test, that's number 1, easy. Okay, now the first line is input. It should be on stats, not on data. It should be on stats because we know the summary stats for the sample. Okay, so bring it on stats, bring the cursor, the black rectangle on top of stats and hit enter so that is flashing on stats. Okay, mu0 is the hypothesized value. Remember, the hypothesized value is greater than, so if I move this a little bit, the hypothesized value, the null hypothesis is over here, 40. So this is your hypothesized value is 40. Okay, so I move it up again. So mu0, so I'm going back over here, mu0 is 40. So mu0 is the hypothesized value is 40. Okay, so type mu0 as 40. Sigma, you know, is 2. That is the population standard deviation is known. That's why we are using the z-test, because population standard deviation is known. Okay, sigma is 2. Then x bar, remember here a sample of 20 and the mean distance thrown by the football player is now 45. So put x bar as 45. N is 20, sample size of 20. Okay. And then the next line, this is the line where we select the alternate hypothesis to tell the calculator. And our alternate is greater than mu0. So bring your cursor, that means a black rectangle, on greater than mu0 and hit enter so that it's flashing on top of greater than mu0. This is the way of telling the calculator what is the alternate hypothesis. And we calculate. So the next step will be to go on calculate and hit enter. So calculate and hit enter. Okay. So, wow, the test statistic, I did something wrong over there to check on that. On stat, let me make sure I've done everything correct over here. Stat, test, z-test. Sigma is 2 actually. I type 6. Sigma is 2. 45, 20. Calculate. Yes, I did everything correct. Prior also the test statistic Z in the next screen is 11.18, same as what we obtained over here. This is also 11.18 over here. Okay, and look at the p-value, same as before, is 2.6 e minus 29. That means equal to point followed by 28 zeros and then 26, which is almost 0 actually. So p-value is less than alpha. Why? Because alpha is 0.05. That's given in the problem. So decision same as before, reject 80. Reject 80. Conclusion same as before, at alpha equal to 0.05, there is enough evidence to support the alternate. Evidence to support H1 or HA if the book says HA, which is what is H1? Mu is greater than 40. So we are supporting the alternate. If we reject the null hypothesis, we support the alternate. Okay, same conclusion as before. So I will stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. And please, if you like my video, give me a thumbs up. I really appreciate it. Please share this video if you like it with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'm coming back next time with another interesting problem, interesting solution. Take care. Have a nice day. Thanks for watching. See you next time.